Hi, I'm Raki from Just Tutors, and today we are going to learn about structure of atoms. In this video, we'll be learning about distribution of electrons in different orbits and valency. So moving ahead, as we all know that number of electrons is different for different elements. So Bohr and Bury suggested a distribution of electrons in different orbits. So there are some rules that we follow when we distribute these electrons in different energy levels. So let's see what these rules are. So the first rule is maximum number of electrons present in a shell is given by the formula 2n square, where n is the orbit number. So the maximum number of electrons in first orbit will be 1 squared times by 2, because for first orbit the value of n will be 1. So 1 squared times 2 will be 2, so there can be maximum 2 electrons in the first orbit. For second orbit the value of n will be 2, so the number of electrons will be 2 times 2 squared, which is 8. For third orbit, the number of electrons will be 2 times 3 squared, which is 18, and for fourth orbit, the number of electrons will be 32, and so on. So now, let's move ahead. There goes rule number 2. So the maximum number of electrons that can be accommodated in an outermost orbit is 8. So this is our rule number 2. And rule number 3 says electrons are not accommodated in a given cell unless the inner shell are filled. That is, first we fill in the first shell, the innermost, then the second orbit, and then third, fourth, and so on. And here we have got this schematic atomic structure of oxygen. As oxygen has got 8 electrons, so we'll start filling in the electrons from orbit 1. In the first orbit there will be 2 electrons, and now as we are left with 6 electrons, we'll fill in them in the second orbit, and that becomes the atomic structure of oxygen. So moving ahead, now we'll be learning about valency. So the electron present in the outermost shell of an atom are known as valence electrons. From the Bohr and Bury scheme, we also know that the outermost shell of an atom can accommodate a maximum of 8 electrons. It was observed that the atoms of element having a completely filled outermost shell show little chemical activities, and such elements are called inert element. Of these inert elements, the helium atom has 2 electrons in its outermost shell, and all other elements have atoms with 8 electrons in the outermost shell. An outermost shell which had 8 electrons was said to possess an octet. And we'll see in the coming slides that every element try to possess an octet. So let's see. Let's come here. So the elements that has got less than 8 electrons in the outermost shell try to possess an octet. So the combining capacity of atoms of the other elements was thus explained as an attempt to gain or attain a fully filled outermost shell. Atom would thus react so to achieve an octet in the outermost shell. This is done by sharing, gaining, or losing electrons. So the number of electrons that atom of an element gain, lose, or share in order to attain an octet is called the valency. So now let's come here. So here we have got an example. So if we talk about lithium or sodium, both of them has got 1 element in the outermost shell. So they lose 1 electron in order to attain the octet. So their valencies are 1. Now can you tell me what is the valency of magnesium or aluminium? So the valency of magnesium is 2 because it has got 2 elements in the outermost shell, and the valency of aluminium would be 3 because it has got 3 electrons in the outermost shell. Moving ahead. So now think, what will happen if an element has got 7 or 6 electrons in the outermost shell? Will it lose 6 electrons or will it gain 2? So let's see what happens. So if the number of electrons in an outermost shell of an atom is close to the full capacity, then valency is determined in a different way. And let's try to learn this with an example. So if we talk about fluorine, it has got 7 electrons in the outermost shell and the valency could be 7. But it's easier for fluorine to gain 1 electron instead of losing 7 in order to attain an octet, right? Hence, its valency is determined by subtracting 7 electrons from octet, thus gives you the valency 1 of fluorine. So now we'll follow the same rule to calculate the valency of oxygen. So let's give it a try. And to try this question, you can pause the video. So valency of oxygen is 2. And let's see how. If you look at the outermost orbit of the oxygen, you will see there are 6 electrons, and it's easier for oxygen to gain 2 electrons rather than losing 6, right? So the valency of oxygen will be 8 minus 6, which equals 2. So the valency of oxygen is 2. So now we can say that an atom of each element has a definite combining capacity, which is called valency. So this is practice time and you can try these questions. And to try these questions, you can pause the video. So here we have got the answers to those practice questions. Oh, I'm sorry. This will be answer number 2. This is answer number 3, 4, and 5. And if you have got all the answers right, then you can pat your back. For more videos, you can log into Just Tutors. Thank you.